Objective 2. Apply the rules of probabilities. In the following probability rules, the notation P of capital E means the probability that event E occurs. Now, the rules of the probabilities are the following. Number 1, the probability of any event E, the probability of E, must be greater than or equal to 0 and less than or equal to 1. That is, the probability of event E has to be in between 0 and 1, and this less than or equal to means that it's including 0 and 1. Now in part 2, the sum of the probabilities of all outcomes must equal 1. That is, if the sample space S is equal to simple event event 1, simple event 2, all the way to simple event E subscript N, then the probability of that event 1 plus the probability of that event 2 all the way to probability of event N is going to total up to 1. Now, a probability model lists the possible outcomes of a probability experiment and each outcome's probability. And a probability model must satisfy these two rules, rules 1 and 2 of the rules of probabilities. So let's take a look at an example here talking about a probability model. So in a bag of peanut M&M milk chocolate candies, the colors of the candies can be brown, yellow, red, blue, orange, or green. Now suppose that a candy is randomly selected from a bag. The table shows each color and the probability of drawing that color. We want to verify that this is a probability model. Now let's see whether this is a probability model. Now in a bag of peanut M&M milk chocolate candies, the colors of the candies can be brown, yellow, red, blue, orange, or green. Now again, we're selecting the candy as randomly selected from a bag, and the table that we see shows each color and the probability of drawing a color. Now you can get this information from the M&M Mars website. Now we want to verify that this is a probability model. To do that, what do we have to show? We have to show that 0, 1, and the sum. We must show that all the probabilities are between 0 and 1 inclusive. So if we look at the first probability, it's 0.12. That is in between 0 and 1. 0.15 is also in between 0 and 1. And if we look at the rest of the probabilities, they are all in between 0 and 1. So therefore, we can say that rule 1 is satisfied because all the probabilities between 0 and 1 inclusive. And now remember that inclusive means up to and including 0 and 1. Now rule 2 is also satisfied. And remember, rule 2 says the sum of all the probabilities must be 1. So let's add up these probabilities. Okay, we have 0.12 plus 0.15 plus 0.12 plus 0.23 plus 0.23 plus 0.15. Okay, and that equals 1. So we can see here that when we compute that value is equal to 1, therefore this is a probability model because it satisfies rules 1 and rules 2. Now, again, what are the key concepts regarding probabilities? Now, if an event is impossible, so if the event is impossible, the probability of the event is going to be 0. Now, if an event is a certainty, then we're going to say that the probability of the event is 1. Now, the closer a probability is to 1, the more likely the event will occur. The closer a probability is to 0, the less likely the event will occur. For example, an event with a probability of 0.8 is more likely to occur than an event with a probability of 0.75. An event with probability 0.8 will occur about 80 times out of 100 repetitions of the experiment, whereas an event with probability 0.75 will occur about 75 times out of 100. Because remember, this decimal can be rewritten as a percent. So therefore, 80% is 80 times out of 100, and 75% is 75 times out of 100. Now, caution. Can you interpret what a probability of 0.7 means? Well, again, it means the event will occur about 75 times out of 100 repetitions of the probability experiment. But be careful of this interpretation. An event with a probability of 0.75 does not have to occur 75 times out of 100. Rather, we expect the number of occurrences to be close to 75 in 100 trials of the probability experiment. The more repetitions of the probability experiment, the close of the proportion with which the event occurs will be to 0.75. And this is from the law of large numbers. Now, one goal of this course is to learn how probabilities can be used to identify unusual events. Now, an unusual event is an event that has a low probability of occurring. Typically, an event with a probability less than 0.05 or 5% is considered unusual, but this cutoff point is not set in stone. The researcher, in the context of the problem, determined the probability that separates unusual events from not so unusual events. Now, the point of this caution is this. Selecting a probability that separates unusual events from not so unusual events is subjective and depends on the situation. Statisticians typically use cutoff points of 0.01, 0.05, and 0.10. In the next objective, we're going to introduce 3 methods for determining the probability of an event: the empirical method, the classical method, and the subjective method.